Welcome to Spring LIB.
Okay, in this problem we have a cube of charges. We can assume that each charge has a charge of little q, and the length of each side of this cube is little l. We are asked the potential at the very center of this cube, and we're asked to find the potential at the corners, and lastly, we're asked to find the total energy contained in this charge configuration. So to start us out, we need to find the distance from one of these charges to the center. We can do a little bit of trig, and we will find that d is going to be equal to the square root of little l over 2 squared plus little l over 2 squared plus another little l over 2 squared. This is just a Pythagorean theorem. No problem there. We end up with 3/4 l squared, or simply root 3 over 2l. That's the distance from one charge to the center. Now, recall that the potential due to a point charge, so v point, is equal to 1 over 4 pi epsilon naught q over r, where q is the charge, r is the distance away from the charge. So for all of our charges, we can insert the distance from the corner to the center, which we just found. So we got root 3 over 2l. Simplify it down a bit. But remember, since we have 1, 2, 3, 4, 5, 6, 7, 8 different point charges on the cube, we got to multiply this by 8 to reflect, using superposition, to reflect the fact that the electric potential is the sum of electric potentials due to all 8 of the charges. That's why we multiply this by 8. So now we can do some simplification. So we got 16 over root 3, 1 over 4 pi epsilon naught, q over l, which is approximately 9.24 times that same 1 over 4 pi epsilon naught q over l. And that's the electric potential at the center. What about the corners? So for corners, this is a little bit trickier. We have, for any corner we choose, we have 3 charges that are L away, have our distance L away. We have 3 charges that are a distance root 2l away. And we have 1 charge that's root 3 away, root 3l away. So we got to count for all of the electric potentials due to these three, and this one separately as separate cases, all added together. So let's do that. V corner is equal to 3, 1 over 4 pi epsilon naught, q over l, plus 3, 1 over 4 pi epsilon naught, little q over root 2l, plus 1 over 4 pi epsilon naught, q over root 3l. And this all simplifies down to 3 plus 3 over root 2 plus 1 over root 3, all times 1 over 4 pi epsilon naught q over l. And numerically, this comes out to be about 5.7 times this and root q and q over l. So that's the potential at corners and at the center. So last thing we got to do is find the total energy. So remember that the energy due to a point charge contained in the field due to a point charge is simply q times v, where this is the charge and this is the potential due to that charge. So in our case, the total energy, total U, is 8 times q times v corner. And then we have to multiply by a 1/2 factor to account for the fact that we are counting pairs twice. So it would say to account for overcounting pairs. So this would come out to be, when we simplify, 1/2 times 8 times Q. Oh, let's do one more step. Let's do it all in one step. So in this case, it would be 4 times 3 plus 3 over root 2 plus 1 over root 3, parentheses, 1 over 4 pi epsilon naught, Q squared over L. That's a epsilon naught. So numerically, this would come out to be 22.8 times 1 over 4 pi epsilon naught, Q squared over L. And I'll fill it in there and box it. And that's it. We've found all the parts for this cube.